Hi, my name is Van Hua. I'll be doing the demo for the Computer Networks project, the Battleship project. Now, we have completed everything from T1 up to T4. For T4, we have selected the compulsory T4.1, and my partner has selected to do T4.4. I'll go into more details later, but for now, I'll run through the fundamental game mechanics. First, we'll run the server. For the first section, I will just have two clients in. I have the username implemented for section T3.3 later, where they will need to be handling disconnect and reconnecting back into the game state. For example, right now, if we have a client named Mick and another client named Linda, they will be put into the game, and then with a prompt, they will give it a prompt to ask if they want to place the ships manually or randomly. This is for T1.3 basic game flow, where it needs to show that each player can actually place ships. For this, I'll have one person placing randomly and one user placing their own ships. Now, it's the same format as the place ships provided, but it's just implemented into a multiplayer sense. For the testing and the demonstration, I will just be placing them all in a line to make it easier for me to complete the game and show you all the other fundamentals of the game and features of the game. We also have made better grid sending for game quality of life, where it would basically show you where your ships have been placed and the opponent's current grid. I will let them fire, so they will be able to command with fire and the coordinate they want to fire to, just like how in T1.1 and T1.4. Oh, sorry, it took too long. That's for later. What's it called? So right now, I'll get them to fire a 1. It would show miss, and then it would show the current grid where they have fired, where your ships have been placed, and what you have fired. I'll do fire a 1 in lower caps now, and it will still be registered as a command because we have censored all of the message sending to be more sanitized and robust, which is done for. Okay, now we also have, if for example, so if they have fired at the same location, it will also notify them that they have fired at the same location, and if they do take too long, the turn will be skipped, just like what 2.3 was specified. I will get this client to fire a 2. And if they do try and make another attempt on a fire where it's not in the part of their turn, so where T2.1 states that if it's the wrong coordinates or out of fire, it will fire B1. It will give them an error saying that it's not your turn, please wait for your turn, and their input will not be saved. And then we'll do fire A1 over here, already fired, fire B1. I will be running through so right now, I'll just run through most of the game, and then I'll run through T3 right now, where I'll add a spectator into the game. Let's say his name is Alex. So he'll be put in the waiting lobby to be waiting for their match, and just like how T3.2 specifies, he will also get live updates of what is happening currently in the game. Yep, fire A5, fire A4, I think I haven't fired yet. And then I'll just run through what it looks like when a ship has been sunk. Fire A5. So it tells you what ship you have sunk and what's it called, and it will show you where it was on the map, on the board, on the other player's board. So that basically specifies all of tier 1 specifications and I think all of tier 2 specifications, because with the disconnection handling, we have implemented the disconnect and reconnect function. So I won't demonstrate T2.4 because we have more in-depth versions of it. We'll now move on to T3.3. Now let's say that this player disconnects on their turn. He disconnects, he terminates. The opponent will get a message tell them to wait for 60 seconds, and that the people in the lobby will also get a notification. So then if he relogs and he uses the same name as Mick, who we put back into the game, will be told that he has reconnected, and then so he can make his move again. Fire B1. Okay, now that I've demonstrated what happens when each player disconnects and what happens on each different turns they disconnect, I'm trying to finish this game and then show what happens after the game is finished for demonstration of T3.4. As you can see here, the game is finished. He has won. So the next game will start between Alex and Mick. So the winner player and whoever's waiting in the lobby. And then we'll just do place random again, and then we'll do place random to show that it actually works this time. Okay, that is 3.4 demonstrated. Okay, now moving on to tier 4s. Now for the demonstration of T4.1, I have done some research and through the lab files, and I found some easy ways to do a compute for the CRC32 checksum. So I've made a checksum, an encode packet and a decode packet, and also a function where it would corrupt a byte in the payload. So I have made a test file for it to show that basically how much packets it is detecting with the decode packets. So I'll run that test file now. So I've just done a simple 1,000 packets sent, and then it is just a simple 30%, and it's detected all of them. I'll go up a little bit higher in numbers now, and even higher in percentage probability, corrupted probability. I will run that again. It will take a bit longer. So yep, it still detects 100% of it. Even no matter how many times I run it, I will run it a little bit smaller this time, so it'll be a little bit quicker. So yep, the amount that is injected does actually change, but it still detects 100% of it all the time. So it does mean that I have securely implemented a custom checksum into the game server. So for 4.4 that my partner implemented, he has decided to do a vulnerability on replay attacks. So what it means is basically, from when we were running the battleship, oh, that is weird. When we are running the battleship, let me run that again. Python. When we are running the game, in case if some user were to, let's say, was trying to make a DDoS attack and trying to basically send a crazy amount of commands at the same time, or like constantly into the server, and it will try and crash the server. Instead, what happens is now that if it's fired at a location, fired A1, right? And then if they try and fire A1 again, it will still tell them that they fired that location again. Okay, but if they try and do replay, it will say if that when they try and replay the last packet, it will say that a replay or out of order packet detected, and it will be ignored instead of being taken in count here. Taken in count here, where it will say where it was actually going through to the server, taking up computational storage. So with this way, it wouldn't take up any computational storage and make sure that the server wouldn't crash if someone were to make a replay attack onto the server. And that'll be all the demonstration. I have demonstrated all parts of the tiers, and that'll be all of it for this. Thank you.